So this is our word problem. The first word problem is we have a light bulb using 120 volts, which is standard, and we can measure that it's drawing 5 amps. Here is a fancy device I can use. I plug in something into here, I plug this into the wall, and I can measure how much current that device draws. So I have 2 questions: how much watts? And the second question is how much heat in BTUs per hour. All right. So we already heard from Robert that watts is power. So we want to know power, right? So this is the first question, is want power. What do we know? What do you know? Well, we know voltage, 120 volts, and we know current, which is 5 amps. Oops. Helps if I spell it out right. And 5 amps is current, which is I. So what formula can I use to determine power if I know current and voltage? Well,
P equals IV.
Great. I know P equals IV. This is my second favorite formula in the electrical world. And I remember it by thinking of poison ivy. P equals IV, poison ivy. So all I do is plug in current, which is 5 amps, times voltage, which is 120 volts, equals 5 times 120 is 500, 600 watts. So that's a lot of watts. That is one heck of a big light bulb, much bigger than your average household light bulb, 10 times as big as your regular old 60-watt light bulb. That's a big ass light bulb. All right. So now here's the challenging question, which is actually question 2. A lot of times with word problems, you want to split them into 2 separate questions. So my next want is BTUs per hour. Right? I want to know what my heat output is to that 600-watt light bulb. It's a big bloody light bulb. I might need to kick on a fan to keep that room cool. So I want to calculate how much my light bulb is. Well, in this case, if you remember my earlier lesson, converting from watts or power to BTUs per hour is simply a matter of looking up a conversion factor. So let me look in my reference book, my pocket reference book, in my conversion areas. To convert from BTUs per hour, I'm going to look up BTUs per hour. BTUs per hour, there it is. 2 watts. I have to multiply by 0.29287. So I get a multiplier factor right out of this book. So 600 watts times 0.29287 equals to some number of BTUs per hour. And it's right here, right in my calculation book. Now, I also could have looked that up in the internet, but it wouldn't have been quite so clean. So now I'm going to get out my high-tech calculator. I'm going to type 600 times, what was the factor? 0.29287 equals 2. So I am generating 175.72 BTUs per hour. Any questions on this one? So the first question was just using the formula P equals IV and plugging in the numbers. And the second part of that same question was just using a conversion factor. So it was a little bit complicated because I had to do a conversion for the second part. Let's go on and do a second one, also power related. All right. I have an oven. I'm running at 20 amps. Oh, this pretty much is the same question as before. Yeah, let's skip that one because it's obviously P equals IV, you multiply 240 by 20, and that's how many watts it is. So let's skip that one. Now let's do a different question. An LED draws 4 volts, right? You have a 1 watt maximum in that LED. What resistor do you pick? If your resistor is too small, your LED won't be at its maximum brightness for 1 watts. If your resistor is too, if your resistor is too large, it won't be as bright as it should be. If the resistor is too small, then you're going to cook your LED. So we have to pick a resistor that's perfect for 4 volts and 1 watt. So let's do this word problem thing. What do I want to know? Anybody?
Resistance.
The resistor, R. What do I already know?
Power and voltage.
I know my voltage is 4 volts. And the actual way of calculating resistors means you're subtracting one voltage from another, and we're not going to do that. We're just going to assume that you have a maximum of 4 voltage. And we know my power is equal to 1 watt. So we already know that. So what formula do I have that will relate V and P and R? Don't forget that V is sometimes called E, electromotive force in some books. V and P and R. Well, I could look it up on the internet using Google, or I could grab my Uglies reference book, and I could use this chart right on the front of the book. If remember, we use this chart by selecting in the center what we want to calculate, in this case, R, and then selecting the formula for R that has all the things that we know in it. So, which formula is both voltage as well as power? Well, in this case, in the case of Uglies, they use E instead of V. So the one I'm picking is right here. So, but I'm going to convert it to V instead of E. And we're going to say P equals V squared. R is equal to V squared over P. Okay, so I just take V squared, which is 4 times 4, which is 16, divided by P, which is 1, equals 16 ohms. Now, ohms is your typical resistance unit of measure, and I draw it by using the Greek ohm symbol, and that's pretty much what you're always going to see when you see resistance. You'll see this little Greek ohm symbol. Any questions about this one? No? All right, I'm going to